Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Hello everyone. Today we have a group assignment for instrumentation measurement and control. Our group Ayad Kadum and Omar Adam and Saif Ali. The contents of this assignment: introduction, sensor selection, signal condition, type of ADC, data acquisition, system design. So in the introduction, the automotive designing can be used different types of sensor. So these sensor will solve a possible problem like repairs and servicing, so on. First sensor we have temperature sensor. This sensor is most significant sensor used in automobile, because if without this sensor the driver will not be know about the temperature if it's go high, so it will spoil it the devices and the engine. So for the temperature sensor we select LM57 on this data sheet. For this sensor we have the range here from -40 to 160, and we have also the voltage 5.5, and also we have accuracy 1.3. Second sensor we have speed sensor. This sensor in automotive can be connected to the crankshaft, so it will measure the speed and tell the driver about the speed in if he go so fast. Some sensor give sound to make attention to the driver. For the speed we select VLS-DA, this type of the speed sensor. So we have here the range of the speed to 6000 RPM, and we have here the accuracy and here the voltage. The third sensor we have pressure sensor. The main function of this sensor is in automotive to monitor the load of an engine. So for the pressure sensor we select MEAS EPB, and the maximum pressure 350 bar, and also we have here the accuracy 0.5, and here the diameter of this sensor, and also here we have the voltage from 10 millivolt to 125 millivolt. The last sensor we have engine knocking sensor. It is to ensure whether the fuel is burning smoothly, so it will cause an unexpected ignition. So this is the data sheet of engine knocking. So we have here the voltage, input voltage 0.05. So now we will have the types of signal condition. The first signal condition for the temperature sensor for the LM57. So why we use signal condition? We want to make the voltage of the sensor 12 volt, because the car volt is 12. So and the voltage of this sensor 5.5, so you will use this amplifier to change the voltage from 5.5 to 12 by using these data questions. And then we will have, after we do this one, we will have the minus 12. So we need another amplifier to unity amplifier, and we will change it to the positive value. Signal condition for the speed sensor VLS DA, we have 6000 RPM, the range from 0 to 6000, and also we want to change the voltage. Here we have 5, the voltage, want to change it to 12 by using this also 2 amplifier. The third signal condition we have for the pressure MEAS EPB, the input voltage we have 1.2 millivolt, and also we want 12 volts in the final because for the car. Also we will do the same things, same question, and we will change it and then to the negative, and then we'll use this to change it to the positive value. The last signal condition for the engine knock sensor, we have here the input voltage 50 millivolt. Also we will do this and then assume RF 24 kilo ohm and R1 100 ohm, and then we will get minus 12 volt, and then we use this one to change it from minus 12 to 12. Here this one the RF and this one R1. Now we will go to the types of ADC, analog digital converter. In this stage we will change the signal condition to the digital output to make sure the computer can read it. So for encoding of temperature sensor LM57, we have the accuracy 1.3 and the temperature 160 and the voltage 12. We'll get the resolution. From the resolution we will get the number of bits of this sensor, 7 bits. For the 7 bits, this binary number, and we will get the decimal number 127. By using this table, we'll get from the analog numbers and change it to decimal, and then we'll get the digital output code. Encoding for the speed VLS DA, we have the resolution 1.5 millivolt, and then we will get the number of bits 10 bits. From the binary 10 bits we'll get the decimal number 1023. Also we will use this table to get digital output code. The third encoding for the pressure, also we have the accuracy 0.5. From that we will get the resolution, this one 300, the maximum pressure bar, and we will get the 10 bits from the resolution. From the binary number 10 bits we'll get the decimal number 1023, and then we will use this table to get digital output code. The last encoding for the engine knocking sensor, we have the resolution 50 millivolt. From that we will get the number of bits 8 bits. For the 8 bits binary number we will have the decimal number 255, and then we use this table to get the digital output for the computer display. Now we have data acquisition of temperature sensor. First we have the temperature sensor ALM57 with the 5.5 voltage. So we will use this signal condition amplifier to change it to 12 for the car, and then we have to change this analog to digital converter. Use this stage to change it to digital to be suitable for reading of the computer, and then the display here we have it encoding, and so this one also called computer. Here we have complete system design for all four sensors. Here we have for the temperature, for the speed, pressure sensor, engine knocking sensor, and then from the sensor we should change the voltage by using signal condition amplifier. For each one there is a type, and then by using multiplexer we will do switch between these signal condition, and then after that we will change analog to digital converter, and then we have computer display, and that's all. Thank you so much for your attention. Have a good day. Goodbye.